Hello once again, this is Sean talking you through Practice Set 4 Paper 3, which is a calculator paper from AQA's pre-released Practice Set materials. So you need a calculator for this one or you'll be struggling quite fast, I imagine. So let's have a look at the first question in any case. Question 1, what's a mode of these numbers? Well, the mode of a set of numbers just means the most common number. So the mode is the most common. It's the number you see crop up most. And so if we have a look here, what number do we see most of? Fortunately, these are already put in order of size for us. So there's a 1, 3, 1, 4, 2 6s, and only one of every other number. And so the mode in this case is 6. And so that's the one we need to circle. Question 2, it asks what is the value of 3 in the answer to 13.78 divided by 100. So it's not asking for the answer, the value of 3 now, it's asking for the value of 3 after we've divided by 100. So the trap you can fall into is to say that it's that 3 is 3 units. But we need to divide by 100 first. And so 13.78 divided by 100 comes out as 0.1378. And so the value of a 3 now is where this 3 is within the number. And so because we're only interested in the 3, as far as we're concerned, all the other numbers may as well turn to 0. And so if we think of this number now as the 3 kept in its place, all the other numbers changed to a 0. We can see what that would be equal to. So if we type in 0.0300 and press equals, the 3 is equal to 0.03. And so that's the answer we need to be selecting. Question 3, we're asked for the largest 2-digit prime number. So let's have a look. 93 isn't prime because that can be divided by 3 and divided by 31. 95 isn't because it ends in a 5 and is bigger than 5, so that can be divided by 5. 99 isn't prime, that can be divided by 3. So the largest 2-digit prime number must be the one that's left, which is 97. I'll show you a way how you can check if a number is prime or not on your calculator. So it's worth showing you this little tip. What you can do, type in the number, press equals, and then press shift fact. That will then do the prime factorisation of the number in question. So if a number isn't prime already, it will change from looking as it is now to as it's written as a product of primes. So 93 isn't prime because we can break it down into 3 times 31. Again, if we try 95, press equals, shift fact, we see 95 can be divided by 5 and 19. But with 97, if you press shift and fact, nothing at all happens. And the only time nothing at all will happen is if a number is already prime. And so that's a way you can just check on your calculator if a number is prime or not. Question 4. Which ratio is not equivalent to ratio 3.4? Circle your answer. And so I hope you remember that to simplify ratios or to change ratios, we change them in the same way as we change fractions. Whatever we do to one side, we do to the other side. And so I'm just going to write down the ratio we're comparing these to underneath all of them here. So if I have a look at this one here, the 1 has become a 4. So what has 1 been multiplied by to change it to a 4? 1 must have been multiplied by 4. So let's check what 3/4 multiplied by 4 is. Three quarters multiply 4 is 3, which is what we've got here, so that's okay, that one works. Looking at this number here, that 1's changed to a 3. And so what's 1 been multiplied by to change it to a 3? The answer is 1 times 3 gives us 3. If we've multiplied this side by 3, we will need to have done the same to the other side. Otherwise, this ratio won't be equal to that one. So let's just try what 4/3 multiplied by 3 is. What we do to one side, we do to another. Sorry guys, that's multiply by 3. So let's try 4/3 multiplied by 3. That checks out too. That's 4. In a similar way, this one here, from 6 to 3 and 8 to 4, both numbers have been halved. So again, that fits because it's a case of what we've done to one side is what we've done to the other side. Half of 6 is 3, half of 8 is 4, so that one works. But this one over here, to go from 1 to 3, again we'd multiply by 3, but if we do the same to 1.3 and multiply that by 3, will that be 4? It won't, it'll be 3.9. So although it's similar to 4, it's not exactly the same. So for that reason, this ratio here is not the same as 3/4. So that's the one we need to circle. That's the one that isn't the same. Question 5. We've got a drink stall that sells sandwiches and drinks, and there's an offer here that says buy a drink and a sandwich for £3.25. This family buy 10 items altogether. They buy more drinks than they do sandwiches. They save 60p using the offer, so how much do they pay altogether? Let's imagine there was no offer at all. Let's imagine they just bought a drink and a sandwich and there was no offer. So the standard price for a drink and a sandwich would have been £1.10 plus £2.30. Now £1.10 plus £2.30 will have been £3.40. But the offer we have here is that a drink and a sandwich is £3.25. So if we compare the offer to what the price would be without using the offer, how much money would we save using the offer? So we can work out how much would be saved by doing the price without the offer, £3.40, subtracted from the price with the offer. So the offer saves 15p. The offer used once saves 15p. But this family haven't saved 15 pence, they've saved 60 pence using the offer. And so if they've not saved 15 pence but saved 60, they will have used the offer more than once. So how many times greater is 60 than 15? We can do this directly by just doing the big number divided by the small number, which tells us 60 is 4 times 15. So if they saved 4 times as much money, they must have used the offer 4 times. So 15 multiplied by 4 is 60 pence. So that means we've used the offer 4 times. So if the offer is a drink and a sandwich, so they've used the offer 4 times. They've got a drink and a sandwich, drink and sandwich, drink and sandwich, and another drink and sandwich. So 4 lots of that offer. 4 lots of a drink and sandwich offer is 4 lots of £3.25, which we can work out the price of. 4 times 3.25 is £13. And so far they've spent £13, but it says the family buy 10 items. So far here, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 items. So they bought another 2 items. Could it be 1 drink and 1 sandwich? Or could it be 2 sandwiches? Well, it says here that they buy more drinks than sandwiches. So the other 2 things they bought must have been 2 extra drinks. So £13 plus an extra drink plus an extra drink would be 13 plus £1.10 plus another £1.10. So add on another £1.10 twice, once for each extra drink they have, and that would be £15.20. So the family spend £15.20 at this food stall. Question 6, we've got 2 numbers. The sum, which means when we add them together, we get 35. The second number is 4 times the first number. So we could do this using trial and error. I'll show you quickly how quickly you can do this using trial and error on a calculator. And so first number's 1. 4 times 1 would be 4. That's not 5, is it? Maybe if the second number's 2. 4 times 2 is 8. That's not 35 yet. If the first number was 3, 4 times 3 would be 12. Not 35 yet. If the first number was 4, the second number would be 4 times 4, which is 16. So we're getting closer, aren't we? If the first number was 5, the second number would be 4 times 5, which is 20, which would be 25. Still not quite there. If the first number was 6, the second number would be 4 times 6, which is 24. That'd be 30. But if the first number was 7, the second number would have to be 4 times 7, which is 28. And that works. So the 2 numbers must be 7 and 28. Because these 2 numbers work. I'll show you using algebra if you want a more direct method. So if I call the first number n, the second number is 4 times bigger. So if the first number is n, we can say that the second number, because it's 4 times as big, we can say that's 4 times n, which in terms of algebra we could just write as 4n. So the first number plus the second number would equal 35. We can simplify these n's together. N plus 4n would be 5n, which is 35. We don't want 5n, we want to work out what just 1n is. So what can we do to that 5n to make it disappear? Well, we can divide both sides by 5. Another way of thinking about this is we can move that 5 to the other side, and if we swap the side, we swap the sign. Opposite of multiplying by 5 is to divide by 5. And so n would be 35 divided by 5, which would be 7. And then once you know that, the second number is 4 times as big. So if the first number is 7, the second number would be 7 multiplied by 4, which should be 28. And so using this method, again, you should get 7 and 28. Question 7a, we've got different transformations. So we've got shape x over here, and it says, which of A, B, C or D is an enlargement of x? With an enlargement, if a shape's enlarged, it gets bigger by the same amount in each direction. So for example, if the width gets doubled, then the height of it would also need to be doubled. So for example, this one can't be an enlargement, because this one is 1.5 times as wide, but it's not 1.5 times as tall. I'm going to show you how you can picture this. So if we just copy shape x and imagine it gets enlarged proportionally, which shape would it look like? Well, the only shape which looks the same would be shape D. And so it would be shape D, which is an enlargement. If one shape is an enlargement of the other, they're called mathematically similar shapes. And so one would be D. This one's bigger than x. This one's scale factor 2. It's double as big in every single direction. So D is an enlargement of x by scale factor 2. Part D, we need to draw a shape that's a reflection of shape y. We need to show the mirror line. So we can reflect it anyway, really. It doesn't really matter, but what we could do is reflect it going straight down. And if we were to do that, what happens is each point ends up the same distance away from the mirror line, but on the exact opposite side. So for example, this point here is 2 squares away, so it'll end up being 2 squares away on the other side. So this point here will end up going here. This point at the top is 4 squares away from the mirror line. So after it's been reflected, it will be another 4 squares away on the opposite side. 1, 2, 3, 4. And so this point will end up over here. So if we just mark these in, and that point would be directly below when it's reflected. Then if we connect the points, if we were to pick this mirror line, I'm not saying we'd have to go for this mirror line, the reflection would be looking like that. Another way we could have reflected would be to have reflected downwards. So for example, if we had this blue line as the mirror line, in the same way, the points would be reflected the same distance away from this mirror line as what they begin with. So this point here, the corner, the right angle, is 2 squares above. When it's been reflected, it'll end up 2 squares below. As will this point here. 2 squares above will become 2 squares below. And this point here, which is 1, 2, 3, 4, 5 squares above, that will end up being 5 squares below. 1, 2, 3, 4, 5. Let's then plot the points and join them up. But make sure you've clearly shown on your diagram which mirror line you're using. And obviously only do one reflection. I'm showing you 2, just to give you 2 different examples of what you could do. But only do one reflection. I'm just showing you that there's more than one way of doing it. So one or the other, you need to have a shape reflected similar to how I've done it there. So these are just 2 different examples. This red triangle has been reflected in the red line. The blue triangle has been reflected in the blue line. Question 8 is about a gas company estimating the amount a household will spend on gas next year. So the estimate is £450 excluding VAT. and then VAT is added at 5%. So the household wants to pay in 12 equal monthly instalments. Is £130 per month enough to pay for the gas? So what we need to do first of all is to add on the VAT to the estimate, because the estimate is without VAT. And so we need to work out 5% of 1450. So 5% of 1450, excuse me, percentage means out of 100. So 5 out of 100 multiplied by 1450. Whoops, typed it in wrong there. 5% of 1,450 comes to a total of £72.50. So because VAT is added, what we now need to do is to add on that £72.50 to the initial 1,450 that the price was. So when we add this on, the total including the VAT comes to £1,522.50. £1,522.50. And that's the estimate for the full year. There's now two ways we can proceed. We can either divide that by 12 to get the monthly payment needed to cover it, or we could do 130 multiplied by 12. So one way we could do it would be to divide this figure by 12, which is £126.88. And so to cover this amount, you'd need to pay £126.88. So £130 is more than enough. The second way of doing it would be to say that if you're paying £130 per month, then in a year, we're paying that amount multiplied by 12. So 130 multiplied by 12 comes to a total of 1,560. And so what they're planning on paying is more than enough of what the estimate is going to come to. And so is £130 per month enough to pay for this gas? Yes, it is. And so yes is our final answer there for question 8. Question 9, we have a function machine here, and it asks us to work out the output y when x equals 4. And so we need to work out y, which is at the end, when the input x is 4. And so we start here with x being 4. I'm going to just follow this number machine along as it asks us to do. So the first thing that happens to x, which in this case is 4, is that we multiply it by 6. And so 4 multiplied by 6 would give us 24. So the middle step here is that we have 24. Now after we get that, we're going to subtract 5. And so 24 subtracted by 5 would give us 19. And so y would have to equal 19. So that's our answer to part A. Part B, we need to complete this number machine so that y equals 2 lots of x plus 7. So what we could do here is expand these brackets. So 2 multiplied by x would be 2x, followed by 2 multiplied by 7, which is 14. And so in its expanded form, we start with x. The first thing that happens to x is it gets multiplied by 2. After being multiplied by 2, we add on 14. And all of that equals y. Now, we could have done that if you wanted without expanding the brackets at all. So, without expanding the brackets, we could have thought of this. This is an alternative. I'm not saying you have to do both ways, this is just a different way. So without expanding the brackets, x comes along, and then we add 7. We then get x plus 7. Then all of that x plus 7, the whole bracket, the whole thing gets multiplied by 2. That again would work and would give us what y is. Part C, we've got a different number machine, and we need to find which equation is correct for the number machine. And so x goes in. The first thing that happens to x, the first thing that happens, it gets divided by 2. After being divided by 2, we add 3. And out pops y. So x over 2 plus 3 equals y. So if we write this in the form y first, if we write it so that y is a subject, so y equals, just reverse the order, y equals x over 2 plus 3. And so as we can see from these available options, the one we need to circle is the first one. Question 10, there's been a survey of 1,000 British motorists about if driverless cars are a good idea or not. So some think it's a good idea, some think bad, some aren't sure. Part A, how can you tell that the percentage are not exact figures? Well, if we add all these together, it should come to 100%, because people have to answer either it's a good idea or bad, or they're not sure. This should cover everybody. But if we add up these figures here, 20% plus 34% plus 45%, if these figures are exact, they should equal 100% when added together. So let's just try it. So 20 plus 34 plus 45 equals 99%. So they can't be exact, otherwise they would add up to 100%. So the reason is the percentages do not total 100. They should add up to 100%, but they don't. Part B. So using the percentages given, how many of the motorists thought driverless cars were a bad idea? So don't worry about them not being exact, because we're told to use the percentages given. So don't worry about anything. Use the percentages given. It says how many of the motorists thought driverless cars were a bad idea. So what we're looking at here is this here, bad idea, was 34%. So the number that thought driverless cars were a bad idea would be 34% of the 1,000 motorists. So 34% of 1,000. Remember, percentage means out of 100. So 34 over 100 multiplied by 1,000 would give us 340. And so taking these percentages here on good faith, that would be 340 people that thought driverless cars were a bad idea. Part C, we have to assume now that the percentages are given to the nearest 1%. Work out the largest possible number of motorists who thought driverless cars were a good idea. And so the percentage that thought driverless cars were a good idea was 20%. So let's see how many that would be. So 20% of 1,000 can work this out. It'd be 200 by the way, but just to show you, percentage means out of 100, and multiply by the amount we're talking about, so 200. So it's been rounded to the nearest 1%, and so we can't have more than 20.5% thinking it was a good idea. If it was 20.5% or more, that would round to 21%. So let's just try this. So 200 drivers would be exactly 20%. How about 201? Well, 201 as a fraction of 1,000 would be this. Multiply that by 100. That would give us a percentage. So if it were 201 out of 1,000 drivers saying it's a good idea, that would come to 20.1% exactly. So to the nearest percentage, that would still be 20%. So it could be 201 drivers. That's a possibility. If you try it for different ones, 202 drivers, in the same way, if it was 202 drivers, that'd be 20.2%, which to the nearest percentage point would still be 20%. 203 drivers would be 20.3%. Again, that would still round down to 20. And the same if it were 204 drivers as well. 204 drivers would be 20.4%, and that once again would round to 20%. But if there were 205 drivers, that would come to 20.5%, and 20.5% would round up to 21%, which we can't have. And so the greatest number of drivers we could have, yet it's still round to 20%, would be 204 drivers. Any more, it would round up. So the answer for part C is 204 drivers. Question 11, we've got a table showing the savings for 30 students in 1 week. The first question is, how many students saved more than £5? So the students that saved more than £5 are all these students here. And that's a total of 14 plus 9 plus 5 students, which should come to 28. But 28 saved more than £5. Part B says how many students did not save anything? Well, not save anything would mean £0. So circle the answer. Well, the smallest group of savings is this one here. But if a saving stands for S, and there's 2 people in this category, this symbol here means the savings was strictly greater than 0. If there were a line underneath here, now that would mean the savings might be 0, might be equal to 0, but because it misses a line on the bottom of the inequality symbol, that means the savings for even those students who didn't save much at all is definitely greater than 0. And so no student saved nothing. Another way of saying that is at least something was saved by every student. So we need to circle 0 for 11b. Question 12. Solve 20x equals 4. Circle your answer. And so if 20x equals 4, we can make out x on its own is. That 20 is multiplying the x. So if that 20 swaps sides, it will swap signs. Opposite of multiplying by 20 is dividing by 20. And so x would equal 4 divided by 20, which your calculator should, if you're lucky and got a decent one, will simplify that down for you. 4 over 20, simplify down to 1/5. So x equals 1/5. Another way we can think about it is x comes along, runs into the 20, which multiplies it, and the answer to that is 4. And so if we start at the end and reverse the steps, go the opposite way and do the opposite things, opposite of multiplying by 20 would be to divide by 20. And so x would equal 4 divided by 20, which in fraction form is 1/5. And so x must be 1/5. Question 13. N is an odd number. Take any statements that are true. Now this is just algebra, which is really confusing, or can be. The best thing I'd suggest would be to pick any odd number. And just substitute in that value instead of n. So pick any odd number. So you could even go for the first odd number, which is 1. And just substitute your odd number into these expressions. So n squared plus 1 is odd. Well, let's see. N squared, if n was 1, then n squared plus 1 would mean 1 squared added to 1. And so if we just try that, 1 squared plus 1, let's see what happens. So if n was 1, n squared plus 1 equals 2, which would be even. And so when it says n squared plus 1 is odd, that's wrong, because it would be even. This one, if n is 1, then n brackets n plus 1 would mean 1 bracket, whoops, putting n in again there, would mean 1 bracket 1 plus 1. Again, because using the fact that n could be 1. So again, if we just try this in our calculators, 1 bracket 1 plus 1 would give us 2, which again is an even number. 2 is even, and so that statement is false, so we don't tick it. This one here, is this one odd? Well, if n was 1, n plus 1 would mean 1 plus 1, all squared. So again, if we try this, 1 plus 1 all squared, in terms of BIDMAS, we'd work out the brackets first. 1 plus 1 would be 2, and then we square. So 2 squared, this should be 4, and it is. So again, 4 is an even number, so it looks like all of these might be wrong. Let's try n squared plus 2. Again, if n is 1, n squared plus 2 would mean 1 squared plus 2. Let's try that one. 1 squared plus 2 equals 3. Now 3 is an odd number. So we can say for that one that it's true, because 3 is odd. So that one works. That is true. And so we can tick this box. The next one, n brackets n plus 2 is odd. So if n was 1, that would be 1 bracket 1 plus 2. So let's try this. So 1 bracket 1 plus 2 would be 3 again, which is also odd. And so this statement's true because it is odd. We've checked and it is as it says. So we tick this one. The final one, n plus 2 all squared is odd. Let's try that one. So if n was 1, n plus 2 would mean 1 plus 2 all squared. Any ideas what it's going to be? Try and think what it's going to be before you see it. Did you think it was 9? If so, well done. Now 9 again is an odd number because we can't half it without any remainder. Half of 9 is 4.5, so it's odd. So again, that one again is true. So for this question, we leave the top 3 statements blank, we only tick the bottom 3. And that's question 13 complete. Okay, question 14, we've got Jack and his pie chart, and it represents his time watching the news in January. We're told that altogether he watches 18 hours of news. And the first part of this question is how many hours did he spend watching ITV news? Well, if we have a look at the ITV sector of this pie chart, the ITV part of the chart is a quarter. It's a quarter of a full circle. So time watching ITV would be a quarter of 18 hours. And we can work this out simply enough on the calculator. So 1/4 of 18 will just be 18 divided by 4, which your calculator will tell you. So we've got 2 up here by mistake. 18 divided by 4, or we can just do a quarter of 18. It should be 4.5. Quarter of 18, 4.5 hours, 4.5 hours. And so that's the first part done, that's part A completed. ITV News, looking at this one, which is just a quarter of a full pie chart. Let's have a look at part B. So part B, we need to write down one criticism of this pie chart. I do think this is probably a fairly simple question. A pie chart should have all of its sectors labelled. Each slice is a sector. So BBC, this one's labelled. ITV, Sky, we're not told what this one represents. And so we could just say something along the lines of one sector isn't labelled. One sector of the pie chart is not labelled. And that will do for part B. Just say one sector is missing a label. Next part, it says in part C that in February he also watches 18 hours of news. He watches 10 hours on the BBC, and Jack says this is more than in January because the pie chart shows I watched less than 9 hours of BBC News. Comment on his statement. So what I've got here is the chart from January. So all this just represents January. So if you have a look for January, watching BBC News in January, it says he watched less than 9 hours of BBC News. Well, if this is 18 hours, then this would show that he watches less than 9 hours, because half of 18 hours would mean half of the pie chart. And the BBC sector is clearly less than half. And so, if he watches 10 hours on the BBC in February, 10 hours is more than half of 18. This one for January, the BBC sector is less than half of 18. And so he is actually right. And so we could say a few things. Maybe the simplest would be to say yes, he's correct. So if he says he watched less than 9 hours of BBC News, that's right. So half of 18 hours is 9 hours. And in January, he did watch less than 9 hours. of BBC News. Because here the BBC sector is less than half of the pie chart. So the BBC sector was less than half of the pie chart. And so something along those lines would pick you up a mark. You don't necessarily need to go into that much detail, but as long as you're making it clear that he's right and giving a valid reason as to why Jack is right for Part C. Part D, Jack's saying that if he draws a pie chart for February, the angle for Sky News will not be a whole number of degrees, and this is because 2/18 is not a terminating decimal. Is his statement correct? Tick a box. Well, if in February he watched 2 hours of news on Sky, and again he watched 18 hours in total, then the number of degrees he'd need for Sky TV would be 2/18 of 360, which you can work out directly with a calculator. And so 2/18 of 360 would give him 40 degrees. And so he's not correct. He was saying that it will not be a whole number of degrees. So he's not correct. So it will be 40 degrees. Not any decimal number. So the easiest way of showing why he's wrong, or to see if he is right or wrong, is just to calculate the angle directly. So for a pie chart, the angle can always be worked out by thinking what fraction of a full pie chart are we wanting to this sector to represent. So if it's 2/18 of a total, we'll need to work out 2/18 of the full pie chart, which will always be 360 degrees. And so in this particular case, Jack's wrong. It won't be a terminating decimal. It won't be any decimal at all. It'll actually be exactly 40 degrees. Question 15. We have a triangle, which is apparently the cross-section of a triangular prism of length 10 centimeters. So Ali writes down this working, and we need to check the working and write the correct solution. So for any prism, importantly this says it's a prism, okay? The volume of any prism has a formula. So in this case it's a triangular prism. I'll just make a note to say it's triangular. What we need to do is work out the area of the cross-section. I always think of it as being like the area of the end shape, because the end and the front, the back and front of a prism will always be the same shape. So if it's a triangular prism, we need to work out the area of a triangular cross-section, which I think of in terms of being the triangular end, multiplied by the length. And so let's compare what Ali needed to do with what Ali's actually done. So how do we work out the area of a triangle? So base times height and then for a triangle we always need to divide by 2. So the area of triangular end is this bit, I've just wrote it down here at the beginning. Base times height divided by 2. And then we need to multiply that by the length. Now we are told the length of this prism, which is 10. So if we just put these numbers in, base is 5, multiplied by the height, which is 9, then divide it by 2, then multiplied by the length, which is 10. So, just filling this bit in now. Now we can calculate this with a calculator, of course, because it is a calculator paper. Let's just plug this in and work it out. So base times height divided by 2 multiplied by the length would give us 225. So the volume of this triangular prism will be 225. Now, because the units are centimetres, the units that come out would be cubic centimetres. So that would be 225 cm cubed. And that's the answer for the volume of this particular triangular prism. So this is the correct answer, 225 cm cubed, which is different to what Ali's got, and we can probably see fairly easily why he hasn't got the same as us. It's because over here he did base times height multiplied by the length, but he forgot to divide by 2. And also as well, the volume he just put in centimetres, which should be wrong, because the unit of volume will always be cubic units. And so those are the two little mistakes Ali made. So unfortunately Ali's wrong, mainly because he forgot to divide by 2 and to put the units correctly. And so that's the correct solution here, 225 cm cubed. Question 16, we've got some angle work to do now. And it says to work out the angle x. And so what we could do first of all, as a suggestion, angles in a triangle, you should know they need to add up to 180 degrees. This top triangle, we've got 2 angles, so we can work out the third one here. And so this angle we can calculate by doing 180 minus 85 minus 32. (180) take 85 take 32. Let's try that one. Okay, that comes out as 63 degrees. So the angle in the top triangle is 63 degrees. Now the angle below it, the angle opposite to it directly, will also be the same. So because if this one's 63 degrees, we know for definite that this angle here will also be 63 degrees. Now the way I'd look at this one is it's like an X angle. The opposite corners of an X angle are always equal. So unfortunately they're not called X angles. I think it would be, personally I think it'd be easier to remember if they were called X angles. It's actually called vertically opposite angles. So because this one's 63 degrees, this one opposite will also be 63 degrees. So the angle at C, DCE, equals 63 degrees as well. The reason for that is because vertically opposite angles are equal. So it's because of these lines are highlighted in purple. That's why they're vertical opposite angles. Now looking at the two angles here, we're also told, by the way, that CD equals CE. And because of that, if CD is the same as CE, this bottom triangle has got two sides which are the same. That means that therefore it's got to be an isosceles triangle. So that's going to be key to working out this one. So because of that, we just make a note that the bottom triangle is isosceles. Now with an isosceles triangle, not only are two sides the same, but two angles are also the same. And so if this is x, this other angle here will also be the same. The two base angles of an isosceles triangle are always equal to one another. And so to work out the final step, we need two angle facts. The first one is the more obvious one. We're going to use the fact that angles inside any triangle add up to 180. And the second fact we're going to use is involving this isosceles triangle. And so, looking at this bottom triangle here, angles inside a triangle add up to 180, so that's where we're going to start. So 63, the top one, plus x, plus the other x, will add up to 180 degrees. This can be neatened up slightly. 1x plus another x means we've got two x's. And so 63 plus 2x equals 180. This is an equation we can now begin to solve and work out what x is. So we don't have this 63 in the way, so we can subtract 63 from 180. If we swap the side, we swap the sign. Opposite of plus 63 is minus 63. And so 2x will be 180 minus 63. Let's just work this one out. We get 117. Therefore, what we need to do, if I just make some more space over here, so 2x equals 117. We can divide both sides of this equation by 2 to work out what x on its own is. That 2 is multiplying the x. Opposite of multiplying by x, opposite of multiplying by 2 would be to divide by 2. And so x will equal 117 divided by 2, which comes out as 58.5 degrees. And so x is 58.5 degrees. And that's all we need to do for question 16. We've proven what x is, and so we're done and can move on to the next question. Question 17, we've got a scale drawing problem here. It says on a map the distance between two towns is 6 centimetres, but the actual distance is 1.2 kilometres. We need to work out the scale of the map as a ratio in its simplest form. So what I'd suggest we do first of all is to compare the two things side by side. And so on one side we'll have the map, on the other side we'll have the real life distance. And so the first bit of information we're told is that the map distance is 6 centimetres and that the distance in real life is 1.2 kilometres. Not centimetres, but kilometres. And so, excuse me, what we could do with doing first, if we can, is converting into the same units. So centimetres and kilometres are obviously completely different. So what we need to do is remember how many metres, first of all, makes a kilometre. And the answer to that is we've got 1,000 metres in every kilometre. And so this relation here is in the form of where one number is a 1 and the other number isn't 1. So if the number that's 1 is this one, the number that isn't 1 is 1,000. And if a ratio or conversion relation is ever in this form, we can always change from one unit to the other by either multiplying or dividing by the number that isn't 1. So in this case, we're going to be multiplying or dividing by 1,000. If we're going from kilometres and changing to metres, we're going from a small number to the bigger number. So to do that, we're going to be multiplying by 1,000. And so to go the other way around, from metres to kilometres, we're going the opposite way, and therefore doing the opposite thing, which would be to divide by 1,000. But in this case, we could change this 1.2 kilometres to metres by simply multiplying by 1,000. So if we take 1.2 and multiply by 1,000, that will tell us what 1.2 kilometres is in terms of metres. So using the calculator, if we just get 1.2 and multiply by 1,000, we'll get the answer as 1,200. So 1.2 kilometres is 1,200 metres. Still, the units are different. We've got centimetres and metres now, and so we need to remember another conversion factor, which is how many centimetres make a metre. And the answer to that one is there's 100 centimetres in every metre. And so in the same way I mentioned before, this again is a conversion factor in the form where one number is a 1, the other number isn't 1. And so to change from one number to the other, we're going to be multiplying or dividing by the number that isn't 1. In this case, it's the 100. So to change from metres to centimetres, we're going from a small number to a big number. And so I have to multiply that by 100. If we were going the other way, from centimetres to metres, we'd be changing from a big number down to a smaller number. That would be dividing by 100. We're going the opposite way, and so we'd be doing the opposite thing. But here, we want to change from metres to centimetres. So to change from metres to centimetres, we just need to multiply how many metres we've got by 100. And so if we take 1,200 metres and multiply by 100, that will tell us what 1,200 metres is and what 1.2 kilometres is as well in centimetres. So 1,200 multiplied by 100 gives us 120,000 centimetres. That's a lot of centimetres. 1.2 kilometres is 120,000 centimetres. Now the units are the same. So because units are consistent, we can just simplify this down now. We've got centimetres on the map, centimetres in reality. And so what we can do now is just simplify this down. Now, ratios simplify down in the same way as fractions. And so what we can do to simplify down a ratio is to use the fraction button on our calculator. If we put the small number on top, in this case the number on the left, put it first on top, and the bigger number on the bottom, it will simplify it down for us. And so what does the 6 become? What does the 120,000 become? The 6 becomes 1. And the 120,000 becomes 20,000. And so that's our fully simplified ratio. And so for every 1 unit on the map, that represents 20,000 times as much in real life. And that's question 7, sorry, not question 7, question 17 completed. The final answer will be 1.20,000. Question 18, part A, we've got a distance time graph, and we need to match different stages of the graph to different statements here. So for example, whereabouts was your average speed? 25 miles per hour. And so what I'm going to do first of all is just divide up this graph into its 4 different main sections. So what I'm going to do is just divide it up into the parts which represent movement. So the first part is from A to B. The second part is going to go from B to C. From A to B, we're travelling away from home. At the end of the section from A to B, we're 50 miles from home. From B to C, we're travelling a bit more towards home. But from C to D, we're not moving at all. On a distance time graph, if a line is completely flat, completely horizontal, that means we're not moving. And so what we can do here is we can just add this in now. So stationary is this flat part here, which is from C to D. After that, we go from D to E, which is this section. And the final thing is when we return home from E to F. Trying to do a straight line here, not doing very well. There. So, the first part where it says the average speed is 25 miles per hour, that just means in plain English that we're doing 25 miles in 1 hour. And so we need to decide which of these moving parts represents a speed of 25 miles per hour. And so we can look at the first part here, the yellow part. Now for the yellow part, the first hour we travel, that's about 16 or 17 miles. And so the yellow part is representing a speed of about 17 miles per hour, roughly. Because that means every 1 hour in time, the distance is increasing by 17 miles. 17 miles in 1 hour means an average speed of 17 miles per hour. Now from B to C, if we have a look from 3 hours to 4 hours, that's a time distance of 1 hour. From 3 to 4 is 1 hour. Let's have a look at how much distance changes between this 1 hour interval. Well, the distance at the top from home was 50 miles. After an hour passes, we're 25 miles from home. And so in that 1 hour, we've travelled 25 miles closer to home. And so this one here represents a speed of 25 miles per hour. And so the average speed is 25 miles per hour for the section which is from B to C. Now, over here from D to E, again if we just compare how much is travelled per hour, from the 6th hour to the 7th hour, from here to here, how much distance is travelled? Well, at this point the distance is 25. In an hour's time, let's have a look what the distance becomes. In an hour's time it goes to 35. So from 25 to 35 in 1 hour, that means 10 miles has been travelled in that hour. In other words, 10 miles per hour. And so the blue section from D to E represents a speed of 10 miles per hour. So once again we can fill this bit in. 10 miles per hour is from D to E. And the fastest part of the journey just means when the slope of a line is at its most steep. We may as well just work out for F how fast it's travelling. So for example, from this point down to 9 hours, well 9 hours is here. Oops. So between here and here, that's 1 hour. And so how far, bit off centre that one, hold on. So between, what distances has been travelled between these 2 points? Well, up here it was 45 miles. Down here it's between 25 and 20. It looks to be about 22.5. And so the purple part, because roughly from 45 to 22.5, that's 22.5 miles in 1 hour. That's the speed for the final section. That's 22.5 miles per hour. And so of these different 4 sections of the journey, which is the fastest part, it's one of the biggest speed. So the 25 miles per hour section is the fastest part, and that happened from B to C. And so we again put from B to C. And that's part A complete. For part B of question 18, we're asked how far is the whole journey? Well, the distance travelled is the total distance travelled between these 4 sections. So we've got the yellow section where we're travelling away from home, and the green section from B to C where we're going a bit closer to home. From C to D we don't move. Then the blue section where we're travelling a bit further away from home again. And then the return to home, this purple section from E to F. And so from A to B we go from 0 miles from home all the way up to 50. So the distance travelled for the first section is 50 miles. And then for green section, we go from being 50 miles away from home to 25 miles away from home. 50 take away 25 is 25. And so 25 miles is travelled in this green section. From C to D we don't move. Then from D to E we go from a distance of 25 miles from home all the way to being 45 miles from home. So between 45 and 25 is a distance of 20 miles. And finally, the home section, when we return home, we go from being 45 miles away down to returning to home. So that's just 45 miles. So this will tell us the total distance travelled for the whole journey. So 50 plus 25 plus 20 plus 45 comes to 140 miles. And so that's the answer to question 18, part B. 140 miles was travelled in total. Question 19 is about speed, distance and time. So in this case we've got an aircraft leaving an airport A and getting to B. So we're told the distance between the 2 airports, and we're told now that the aircraft leaves A at 9:30 and arrives at B at 11 o'clock. We need to work out the average speed of the aircraft, and we're going to assume that the aircraft travelled the direct route. And so if it's a speed, distance, time question, we can use, as long as we're careful, I'll come to that in a second, the speed, distance, time triangle. And so because we want to work out the speed, what we do is we cover up the speed and have a look what's left. Whatever's left in the triangle and the order in the triangle it appears tells us what to do with what's left. And so what we've got is distance on top and time on the bottom. So that tells us that speed equals distance on top and distance travelled divided by the time taken. So if you notice as well the units of the question, we want the answer to be in kilometres per hour. So distance travelled, we've been told that the distance travelled, because we're going to assume it travels the direct route, is going to be 450 kilometres. The time taken is where we need to be careful. If it leaves A at 9:30 and gets at B at 11 o'clock, the time taken is going to be 1.5 hours. Now 1.5 hours, I would suggest putting in as 1.5 or 1.5. A common mistake here would be to say that from 9:30 till 11:30 is going to be 1.3 hours or 1.30 hours. That's not true. It's definitely not going to be 1.30 hours, because 0.30 means 30% of an hour, which should be 18 minutes. 0.30 doesn't mean half of an hour. Half an hour is 0.5. So I'm going to come to an alternative method in a second, which I think will make it less likely you'll fall for this mistake. But if you're using this formula method, take care to say that the time taken is 1.5 hours, or 1.5 as a mixed number. From 11 till 9:30, that's 1.5. So that's where the 1.5 comes from. And so if we then type this into the calculator, distance on top, which is 450, time taken underneath, which is 1.5 hours, we're going to get 300 kilometres per hour. So the answer for part A is 300 kilometres per hour. I did say I'm going to mention another way where you can think of speed. You can think of speed as how far we travel per unit of time. And so what we could do is think of this in terms of minutes as well. From 9:30 till 11, 9:30 till 10 would be an extra half an hour, 30 minutes, and from 10 to 11 would be an extra 60 minutes. So we can think of this time frame from 9:30 to 11 as being 90 minutes. And if you think of it in terms of minutes, it takes away this possible decimal confusion when we're dealing with time. And so what we can think of it in this way is that we travel 450 kilometres in 90 minutes. From that we can work out how much will be travelled per minute. So to go from 90 minutes to just 1 minute, what could we divide by to get from 90 minutes to just 1 minute? Well, the answer to that is any number divided by itself would give us 1. And so we could divide both values here by 90. So 450 divided by 90, that would tell us how far the airplane's travelling in a minute, which would be 5 kilometres every minute. That's 5 kilometres in 1 minute. But because we want the answer to be kilometres per hour, how can we change from 1 minute to an hour? Well, an hour is 60 minutes. So what could we multiply 1 by to get to 60? The answer to that is 1 multiplied by 60 will give us 60. So what we can do is multiply both values now by 60, and that will tell us how many kilometres the plane travels in 60 minutes. 5 times 60 is 300. So it travels 300 kilometres in 60 minutes, but because 60 minutes is an hour, that means 300 kilometres per hour. So just a slightly different way you might want to think about it. Or if you're comfortable using the speed, distance, time triangle, by all means this can be used as well. Part B says the aircraft did not travel the direct route. How does this affect the average speed? Well, if it didn't take any longer than an hour and a half, but it went even further, it must have travelled faster. And the reason for that would be it travelled a greater distance than the direct route, but didn't take any longer to do so. So words to that effect would get you marks for question 19 part B. It travelled a greater distance than the direct route, but it didn't take any longer to do so. Question 20. Sam's done this method here, presumably for working out some sort of calculation, maybe Pythagoras, I'm not sure. And it says, what's wrong with his method? Give the correct answer. Well, one thing you needed to do first was to actually work out 13 squared minus 5 squared. So what he should have done, he needed to calculate 13 squared, which is 169, and also 5 squared, which is 25. Then he should have done one take away the other. (169 minus 25), which is 144. Finally, then he needed to square root 144. So finally, he should have found the square root of 144. So for the correct answer, we can calculate using a calculator if you'd like, or you can do that step by step as I've suggested. So what we need to do, type in the square root and type in exactly as it appears in the question. So 13 squared minus 5 squared, all within the square root symbol, press equals, now we should get 12. If the square root of 144 is 12, so by putting 8 he's made quite a few mistakes there. Part B either writes 4 squared times 4 squared times 4 squared equals 4 to the power 2 times 2 times 2 equals 4 to the power 8. Now when we're multiplying, what we do is we add the powers together. So she should have added the powers together, not multiplied them. So what she should have got is 4 squared times 4 squared times 4 squared, which is 4 to the power 2 plus 2 plus 2, which is 4 to the power 6. So the final answer should have been 4 to the power 6. Or if you wanted to, you could have given this as a numerical answer. So 4 to the power 6, or you can just type it in exactly as it appears in fact. 4 squared times 4 squared times 4 squared, 4096. That's what she should have got, not 4 to the power 8. And the reason why this rule exists for indices is it does make sense. 4 squared just means 4 multiplied by itself twice, as does this one here, as does this one here. So it makes more sense if you write it out longhand actually. 4 squared means 4 times 4. Same here, that's 4 times 4. That means 4 times 4. So I'm just trying to explain where this rule comes from. So if you multiply this one by this one, finally by this one, how many times are we multiplying 4 by itself? 1, 2, 3, 4, 5, 6. So that's why we add the powers together. So when the base values are the same, and we're multiplying the base values together, and there are powers involved, these little numbers, we add the little numbers together rather than multiplying the little numbers together. 21a says write these numbers in ascending order. So first of all, I'll just try and clarify what ascending means. So you might ascend a mountain. So ascending means going up. So if that word throws you, ascending means from smallest to biggest. The other way around is descending. If you descend some stairs, for example, it means you go down the stairs. So descending means going down. So in this case, we're only talking about ascending, which means going up. So we need to work out which is the biggest number. So 9812 is obviously just 9812. This one here, 9.82 multiplied by 10 squared. Let's calculate this one. Multiplied by 10 squared. That's 982. This one here, 9.81 multiplied by 10 cubed times 10 to the power 3 is 9810. And so the smallest number, let's just rate them. The smallest number is the middle one. Now, the number as written is 9.82 multiplied by 10 squared, not 982. So put the answer in terms of what the number was in the original question. So 9.82 multiplied by 10 squared. Then which is the next smallest after that one? The answer is this one's slightly smaller. This one's smaller by 2. So the next number would be 9.81 multiplied by 10 cubed. And the biggest number goes last. That's 9812. And so that's part A done. This is the numbers from smallest to biggest. Part B, John's multiplying two numbers given in standard form, and he's taking 2 times 10 to the 6, that's his first number in standard form. The second number he's multiplying is 3 multiplied by 10 to the power 7. And so what he's trying to say is we can take the first two numbers, the numbers between 1 and 10 in standard form. For example, here 2 times 3 is 6, and then we can just take the powers of 10, put them at the end, and add together the powers of 10. So let's try this one. Let's see if he's right. I'm just going to show you how your calculator can do standard form for you. It's a good opportunity to just show you how. So 2 multiplied by 10 to the power 6 multiplied by 3 by 10 to the power 7. We get this answer, which in standard form That's correct. Standard form means the first number needs to be between 1 and 10. 2 times 3 is between 1 and 10, 6. And times 10 to the power 13. So he's correct here. And yes, that is in standard form. But let's see what he's saying after that. He's saying that for any numbers, one multiplied by the other can be written like this, and that will always be in standard form. So is he correct? Well, he's right in this case, because 2 multiplied by 3 is 6, which is in between 1 and 10. But how about if he picked different numbers? What if his first number in standard form was, just for example, 6 multiplied by 10 to the 6? And keep that number as it was, times 3 times 10 to the 7. So the power of 10 would be 6 plus 7, which should be 13. But 6 multiplied by 3 would be 18 times 10 to the 13. If you try this as well on the calculator, so I've just took the same values, but instead of 2 multiplied by 10 to the 6, just for example, I'm picking 6 times 10 to the 6 and seeing what would happen. You see, we don't get 6 plus 7, which is 13. We'd get 1.8 multiplied by 10 to the 14. And so this wouldn't be in standard form. So he's not always going to be correct. So it only works. He's not correct. So this calculation would be an example to show him why he isn't correct. So that could be one reason of explaining why he's incorrect. A second reason, to put it in words, would be something like this. I think the easiest way is to show the calculation as a counterexample of why he's not always right. But in terms of explaining it, it would only work if this part here, a multiplied by c, is a value less than 10. Because of standard form, the first number needs to be between 1 and 10. So for example here, 6 times 3 is 18. That isn't between 1 and 10. That's too big. And so John won't always be correct. He will be sometimes, but sometimes he's not going to be correct. So in general, he's not right. Question 22, when we need to factorise a quadratic expression. This time we need to factorise x squared minus 9x plus 20. Now there is a tip to doing these, there's a little trick if you like. What we need to do is we need to be thinking of two numbers that when we add them together give us the coefficient of x. Coefficient is just a fancy way of saying the number in front of the x. So it's not just a 9, it's a minus 9. Always take into account the sign in front of the thing you're dealing with. And so we need to think of two numbers that add up to give us minus 9. And these same two numbers, when we multiply them together, that needs to give us the number at the end, which is positive 20. You can put plus 20 if you like, or just leave it as normal 20. So we can do this using a trial and error approach. I mean, with practice you can get quite quick at doing these. But thinking of it at first, if we're adding two numbers together and we get a negative outcome, We know for sure then that at least one number has got to be minus. If we add together two positive numbers, there's no way the answer can come out as being negative. So we know for sure from this one at least one number must be negative. But when we multiply them together, we have to end up with positive 20. Now, if we took a negative number and multiplied it by a positive, if we multiply things together with different signs, it makes it a minus answer. So the only way that one of them can be negative and we multiply them together and we get a positive, the only way that can happen is if the other number is also a negative. Because a minus value multiplied by a minus value will come out to be positive. So piecing this together, we know that both numbers must be negative. And so from that we can just try different numbers together. What I'd suggest would be to think of the 20 first, to think of the number they need to multiply together to give. So what two numbers multiply together to give 20? Forgetting the minus signs for a second. Well, we could have 1 multiplied by 20. We could have 2 multiplied by 10. Or there's also 4 multiplied by 5. And bearing in mind that both numbers need to be minus to give us minus 9, we can then just try them on our calculator just to see which one works. With practice you can be able to do these without using a calculator, but since it's a calculator paper, we may as well use the calculator to our advantage. So minus 1 plus minus 20, will that come to minus 9, I wonder? No, minus 1 plus minus 20 would add up to minus 21. So although minus 1 and minus 20 work for the last section, they don't work for this bit here. They don't add up to minus 9. We need to find a pair of numbers that fit both these two things. Let's try adding together minus 2 and minus 10. Minus 2 plus minus 10. That gives us minus 12. Still not minus 9. But if we try this one, minus 4 added to minus 5, then that does give us minus 9. And so the two numbers at work, that when we multiply them together, give us 20, and when we add them give us minus 9. The numbers we need are minus 4 and minus 5. That's the hard part done. The next part is much more straightforward. We put an x at the beginning of each bracket, because x multiplied by x is how we get x squared. The second thing is, in any order, we put these two numbers into the brackets after the x's. And so one of the numbers after the x is a minus 4, the other number is a minus 5. So that's our fully factorised answer. X minus 4 in brackets, then x minus 5 in brackets. Part B, we need to solve this equation now, equal to 0. Now if you notice, this is the same thing as what we had in Part A. X squared minus 9x plus 20. And so we use our factorised expression from Part A. And what we had was x minus 4, x minus 5. And so we can think of this in factorised form, which makes it easier. So this whole thing needs to equal 0. So how can that happen? Well, what we've got here is one bracket multiplied by the other, and the answer is 0. I'll give you the short way of doing this after, because it's a 1-mark question. There is a very quick tip to doing this. What this means though here, just to explain why the answer is what it is, you've got bracket 1, nothing in between these two brackets telling us what's happening. So it means one bracket multiplied by the other needs to give us 0. Well, if we multiply two things together and the answer is 0, That can only happen if one of the things we're multiplying is 0. So either bracket 1 is 0, or the second bracket is equal to 0. If the first bracket is equal to 0, that means that x minus 4, what's inside the bracket, is equal to 0. We can solve this equation easily enough by swapping the minus 4 to the other side, and when we swap side, we swap sign. So add on 4 to both sides in effect. So for the first bracket to be equal to 0, x would have to be equal to 4. Or perhaps the second bracket is the one which is 0, in which case that would mean x minus 5 equals 0. And if that were the case, again, if we solve this one-step equation by adding 5 to both sides, or swapping side and swapping sign, for this one we get x equals 5. So that's the logic behind why the answer is x equals 4. Or, because it's got two answers for this one, x equals 5. So you need to give two solutions. So x equals 4 or x equals 5. Now I'm going to mention the shortcut way. Look at the numbers in the brackets. The minus 4 becomes positive 4. X minus 5, one of the solutions is x equals plus 5. And so the shortcut way to doing this is we have the same numbers which we find in the brackets, but we just alter the signs to the opposite. So for example, if this bracket were x plus 4, one of the solutions would be x equals minus 4. If this were x plus 5 in the bracket, this answer here would become x minus 5. And so we keep the numbers the same, but we just swap the signs to the opposite things. So that's a quick way for doing questions like question 22. Question 23, we've got the dreaded simultaneous equation problems. With simultaneous equations, what we need to do is to get rid of either the x's or the y's. And the first thing we need to try to do is make sure the number of x's is the same in both equations, or the number of y's is the same in both equations. Don't worry if they're positive or negative, just look at the numbers in front. So the y's are different, we've got a 2 here and an invisible 1 here, but the numbers of x's are the same. So because we've got the x's which are the same numbers, we're good to go. So what we can do here is just do one equation, take away the other one. The idea is to just get rid of the x's or the y's. So if we do the top equation, take away the bottom one, that will make all the x's disappear. And so dealing with the x's first, 3x take away 3x's will give us no x's at all, which is just what we want to happen. Next for y's, 2y on top, take away minus y on the bottom. Now 2y minus minus y is the same as 2y plus y, because two minus signs together act as a plus. 2y minus minus y is the same as 2y plus y, which will give us 3y. And finally, the values at the end, 10 minus 13 will be minus 3. And if you're not comfortable with minus numbers, your calculator is always here for a calculator paper to help you out. So that tells us that 3y is equal to minus 3. We want to have just one y on its own. So if 3y is minus 3, we can get y on its own by just swapping this 3 here over to the other side. But if we swap side, we swap sign. That 3 is currently multiplying the y. Opposite of multiplying is dividing. And so y will be minus 3 divided by 3. which would be -1 if you were to check it. And so y equals -1. So put that down before we forget to. We've got a mark in the bag now. The second thing to do is then to substitute this value for y back into one of the initial equations. So we've worked out what y is, which is -1. We can then put this value for y back into either the top or bottom equation. So if you're not sure, flip a coin, doesn't really matter, or just pick whichever one looks to be the easiest equation. I'm going to pick the top one. And so what we're going to do is put this value back into the top equation. Put y equals -1 into the top equation. So this is the top equation. We have 3x plus 2y. And so plus 2y means 2 multiplied by -1, because y is -1. 2 multiplied by -1 gives us -2. So we have 3 plus -2, which equals 10. Now, if the signs next to each other are plus and minus, mixed makes minus. So adding a minus is just the same as subtracting. So we can replace this plus minus with a minus. Now we can solve this. So we need to have the x's on their own, so we can get rid of this -2. If we swap side, we swap sign. Opposite of -2 is +2. So 3x will be 10 plus 2, which is 12. Then to go from 3x's to just 1x, we can divide by 3. So divide both sides of the equation by 3 now. We can think about 3 as moving sides and swapping signs. Opposite of multiplying the x by 3, opposite of multiplying by 3 is to divide by 3. So x will be 12 divided by 3, which is 4. And so the full solution for question 23 is that x equals 4 and y equals -1. Question 24, we've got a formula for the diagonal of a line from one corner of the cuboid to the opposite corner. And so we're told A, B and C in this formula. So the formula is whatever A is, we're going to square it. Then whatever B is, we're going to add that on, or the square of it and add it on. And finally, we're going to take what C is and square that too. So it's going to be these three squares added together and then square rooted. So for part A, we need to substitute in different values for A, B and C. So for part A, we're told that A is equal to 8. We're told to use that B is 3. And we're also told to use that C equals 2. And so we're going to use this formula here and just substitute in the values. And so it's the square root of A squared. Well, if A is 8, that'll mean 8 squared. If B is 3, B squared will mean 3 squared. And finally, if C is 2, C squared will mean 2 squared. And so we're using 8 for A, 3 for B, and 2 for C. And so if we just type this into our calculator, we'll get an answer for it soon enough. And so the square root of 8 squared plus 3 squared plus 2 squared will give us 8.774964387. So let's just write down all those numbers first of all. we've got 8.77, 496, 4387. But look at the question, and we need to give our answer to two significant figures. So what it means is we need to keep the first two non-zero numbers in our answer and round those. So the first two significant figures are the 8 and the 7. First significant figure, that's the second. And so we need to round off at this step here. So we just want to keep the 8, and maybe we want to keep the 7. I say maybe because we need to look next door to the 7 to see whether it keeps as it is or it rounds up. Next to this 7 is another 7, and so this 7 here is going to round up to an 8. And so to two significant figures, the length of this diagonal will be 8.8 centimetres. Part B now for question 24. We're told to work out the length of the diagonal in terms of A when B equals 2A and C also equals 2A. And so A is going to be just kept as A. B is now going to become 2A. And finally C as well is going to become 2A. So if we substitute these values for A, B and C into this formula, A squared is just going to be A squared. B now though is 2A, and so B becomes 2A all squared, and C is 2A all of that squared. So it's not just A squared, it's the whole of 2A all squared. So now we can work this out and neaten it up slightly. And so first of all, A squared, we can just leave as A squared for now. But 2A squared means 2A multiplied by 2A. So 2 times 2, the 2 squared part will become 4, because 2 squared is 4. And A squared, A times A, just becomes A squared. So 2A, all of that squared, is 4A squared. And because C is exactly the same, this thing here also becomes 4A squared. Now we can simplify this down. All these different A's are the same type of A, they're A squareds. So we can group these together. So we've got 1A squared here, plus another 4, plus another 4. That gives us 9A squared. And so the square root of 9A squared, well, the square root of 9 is 3, and the square root of A squared is A. Let's double check. 3A multiplied by 3A. 3 times 3 would be 9. A times A would be A squared, and so it does work. So the square root of 9A squared is 3A. So that's our final answer for part B. It's 3A, whatever A might be, centimetres. Finally, now question 25, we've got a diagram showing two circular arcs with centre 0. And we're asked how much longer is the big arc than the small arc. So this isn't a full circle. Sounds obvious to state, but you need to be thinking and remembering this is not a full circle. So before you dive in and think of circle formulas like pi r squared, just picture it as not a full circle, but like this. It's a fraction of a circle. It's not the full circle. And so if I were to colour code this, we've got a small arc here, which is a fraction of the smaller one going all the way around the outside. and also this bigger one on the outside is just a fraction of the full circumference. So I'm hoping you can see here that the circle we've got in crescent at the top is just 1/3 of a full circle. A full circle is 360 degrees. And so here we only got 120 degrees out of 360. And so 120 over 360. Let's see if we can simplify that down with our calculator device. 120 over 360 is 1/3. And so the types of circle we're dealing with is just 1/3 of a full circle. So just looking here, because it's only 120 degrees, these arcs, an arc by the way is a fancy word for just a portion of a full circumference. These arcs are just 1/3 of the full circumference. So that's worth just making a note of. The arcs are 1/3 of a full circumference. Now we need to be thinking about the formulas for a circle. So there's two main formulas. Each one relates to pi. Pi, the number, also sounds like pie the food. And on the subject of food, chicken pies are delicious. Apple pies are too. Now C doesn't just stand for chicken, C stands for circumference. A stands for area as well as apple. The one we're interested in this time is C for circumference, because we're only interested in the lengths of these arcs. We're not interested in the area of the sector, it's the lengths of these bits here. So we're interested in C equals pi d. And so what we can do now, as a suggestion, would be to think about the small arc and the big arc separately. Or the smaller arc at least and the bigger arc. So thinking of the smaller arc first, the one I've done in yellow, this one here. Now, this arc here is part of a circle with radius 4. So the diameter is always going to be double the radius. So the diameter will be 4 multiplied by 2, which is 8 centimeters. Now we know that, we can say that the small arc is 1/3 of the circumference. It's 1/3 of pi times diameter. So really important to remember it's going to be 1/3 of a full circle. So 1/3 of the full circumference, 1/3 of pi multiplied by the diameter, which should be 8, we can work out on the calculator by just doing that fraction, 1/3 of the full circumference. And so we do pi by pressing shift and the pi button, then multiplied by the diameter, which would be 8. And as a decimal we get 8.3775 and so on. 8.3775. 8 maybe. So the smaller of the arcs, the innermost one, has a length of roughly this. Now the bigger one, again we're talking of the same fraction, this time with the larger circle, it's still going to be 1/3. Now the diameter of the bigger circle, the one around the outside, have a look at the radius. From the middle to the outside, the radius is 4, plus this extra 1, which is 5. So the diameter will be the radius of the bigger circle, which we just said is 5, multiplied by 2, which is 10 centimetres. Now we've worked out the diameter, the arc, for the bigger arc will be 1/3 of pi multiplied by its diameter. 1/3 of what the full circumference would be. So that's 1/3 of pi multiplied by 10, which can work out here. So it's the same formula, but instead of 8 for the smaller arc, we're now going to use the diameter of 10, which will give us 10.47197. 10.47. What was it? 197551. And that's the length of the bigger arc. So we're nearly there now. The question's asking us how much longer is the big arc than the small arc. The final step is to do the length of the bigger arc, which is 10.47197,551 and so on, subtracted from the length of the smaller one, which is 8.37758 and so on. So this value here, subtract 8.37758. Now we want our answer to 1 decimal place, and so the first decimal place is a 0, but next to the 0 is a 9, and so that 0 will round up to a 1, because the 9 next to it will make it round up. So to 1 decimal place we've got 2.1 centimetres. And so we write that down on our answer line, and that's the last question, and therefore the whole paper completed. 2.1 centimetres. Thanks for listening again. I hope you found at least some of that useful. Keep working hard. Do ask me if you've got any questions, either in the comments or in person in class, and I'll hopefully see you soon.